Okay, everybody. So we've made a ton of videos over the years explaining a lot of the failure points of the Ecodiesel, or at least pointing in the direction of where the failures are coming from. And we finally have confirmation from a quality machine shop what's causing the main cause of the issue. Everything we've mentioned is a variable to the cause. So it has not come up before from other machine shops, because most machine shops, when they deck the plate and they deck the block, the bottom where the two parts go together, they have to double pass it. The machines aren't big enough. They pass one side, they flip the block, they pass the other side, same with the bed plate. Well, we have switched to a shop that has a large enough machine to deck the whole thing at once. And they deck the motor, they deck the bed plate. And basically, okay, so let's say we got an engine that comes in that's got a spun bearing. Once you have a spun bearing, you need to line bore it. You can't line bore it because it'll open up larger. So we deck the plates to shrink it down and put a standard line bore through. So they decked the block, decked the plate, torqued it together, and found that when they're torqued together, that the middle four parts, which is the middle two mains, visually are connected. They look like they touch, but they're not. They actually found that every single bed plate out of every engine actually has a warp in the middle of it. So the four corners torque down and touch perfectly, where the middle of the motor does not, leaving basically, as you see the crank in here, like this is the main bore. It's gonna be dramatic. It's tight on the end. It opens up for the middle two and then tight on the other end, which leaves room for, when it lugs, for the crankshaft to wobble up and down, which is why typically the middle two bearings spin first. It's also why the cranks crack and break in the middle area, because you're allowing all this flexation and vibration, torque, twisting. There's a million words you can use here that is all happening in the middle, causing the weakest point of the crank to break or tear the bearings up, or a combination of the two. With that being said, what we have developed is basically they have to machine a lot out of the block to make it work. Basically between the top and bottom, it's 28 thousandths, okay? So they machine that out. The rear, where the rear main seal goes, they machine that out to the standard size. From there, what we have to do is put a shim on the crank sensor to space it properly. You have to drill out the holes in the front timing cover for it to fit properly in the right spot. There's a little bit of work where we have to move the pin in the oil pump to get it to fit correctly. And then the last but not least, the lower holes in the transmission have to be drilled out one size. And where the pin alignment pin goes. And then it's fine. These motors can go back in. With that being said, if you have that done, you have it done properly, there's no reason why you can't get away with using the cheaper Chinese cranks. You just have to make sure that everything is balanced. Those cranks are not balanced properly. They need to be balanced to the harmonic balancer, the flex plate, and the rotating assembly, which is the rods and the pistons and the crank together. All that needs to be balanced together in order to use that. With that being said, other than some other issues with the engines, there's no reason why you wouldn't have a super reliable, long-running Ecodiesel motor after doing all of that. Technically, my recommendation is if you have a good running Ecodiesel and you have the time, take the motor out, have all the work done to it before the crank goes out. That way you don't have to buy any new pieces. You can reuse everything there other than some fresh bearings. Get all the machine work done, get some fresh bearings put in, get the motor put back together, and you got a nice, long, solid running engine. A couple other things I recommend. One, for the injector copper ring issue, is that you take the injector hold downs out, and on the leverage ball, you put a small, thick weld bead there, which will cause it to go up a little bit higher and put a little bit more pressure on the injectors. That'll help prevent that. We basically do it on every engine we work on now, because a lot of them, even with new copper rings, when we put them together, they start leaking diesel out of them immediately. So we found that to be the cure for that. Quality oil, obviously. And then the last thing that we don't talk about much is that on an engine that hasn't been deleted, you'll notice that the intake manifolds are just full of crap, full of tons of crap, which we ultimately immediately blame the EGR. You're like, yeah, that's the EGR. Kind of. It is the EGR that is causing the soot buildup. This is a Gen 3. This is much newer. In here, there's still bolts in this one. It's much newer, so there's a lot less in it. There's probably only 20, 30,000 miles on it. What actually is happening is that the positive crankcase ventilation system is depositing oil into the intake manifold, okay? Oil's sticky, oil sticks to everything. The oil sticks to the intake manifold, the EGR opens up, dumps partially burnt fuel in there, which is soot or the black stuff you see coming out of the back of most diesels, rolling coal, whatever, and it sticks to the oil. So it coats the whole system once. So nice 1/16 of an inch or less thick coating, okay? Over time, more oil comes in the manifold and sticks, more soot sticks. And this constantly builds up over time until you get quarter, half, or a whole inch of soot inside these motors. So the cure for that, for most people, is to do a catch can, which partially works. It cuts it down in half, if not more. But if you really want to make your Ecodiesel super healthy and long living, it is to do a vent-tree system, which was super common in the 80s. And some newer diesel systems somewhere, I think, still use it. But essentially what it is, for example, you take this, okay? If you were to take an air gun, so this at home, fill a water bottle up, put a straw in it, take an air gun, blow it across the top of this. You blow it across the top of it, it will suck all the water out of the cup until you stop blowing air. That is basically the vent-tree system, is you actually get a metal rod that you drill a hole and you weld it into the exhaust at an angle, and it has a vent-tree in the pipe, just like you would see in like a carburetor or like the jets of a motorcycle. And as the exhaust passes by it, it creates a vacuum and sucks the pressure out of the crankcase. This will allow all of the oil that would normally go into the intake to go into the exhaust and be burnt off. This would also create a vacuum pretty much almost all of the time on the crankcase, which if you look up and do your own research on it, you'll find that a vacuum on a crankcase will not only generate more power, allow the RPMs to climb faster, and help the longevity of the motor because it's not fighting pressure in the crankcase. For example, almost every Ecodiesel, if you crack the oil cap, it will pop it up off of the oil tower. No other diesel will do that. The Ecodiesel already has super loose tolerances on the cylinders, which generate a ton of pressure, is allowed to go past the pistons into the crankcase. So once you do a lot of these things, you're talking about a motor that has zero reason to not run 500,000 miles. There's no other reason, once all this stuff is fixed, for these to be long-term engines. So just keep that in mind, that if you are gonna have an Ecodiesel and you're not gonna take care of it, it's gonna cost you a lot of money to continue to repair it. It'll also cost you a lot of money to make it reliable, but once you make it reliable, you can drive that truck absolutely forever. We do have a couple other things we're working on, like a larger turbo, which we worked on one in the past, but this time we found a turbo that is all around physically larger, but uses the exact same vane control module or actuator controller that we're going to try and figure out how to mount in the exact same spot or similar, but it's like 20 or 30% larger. So it will no longer be this massive restriction on the engine. So when and where and if we get around to it, I have no idea. But, you know, take this video into consideration. This is not me telling you what the cause is. I mean, yes, it is me in the video telling you what the cause is. But we use a very high-end machine shop that's respected throughout the state, where all the other machine shops send the stuff they can't do. So we have a bunch of motors being worked on by them right now. And so the customers that are currently waiting on engine rebuilds from this point forward are getting engines that have had all this work done to them and should not have any issues.